Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to start with the description of our signals. What are the signals which are associated with our master interface and slave interface, and what are the signals which are present in AXI protocol, and what are the brief description of that particular signals. And in our previous video, we have started with the discussion of AXI protocol introduction and what are the things what are the channels we have in AXI protocol and what are the significance of each and every channel we have discussed in detail. If you haven't watched that particular previous video, I recommend you to please go and watch that, and you can continue with this particular video. Yes, so let us start with the very first signal which we are going to have is clock, and the very first signal which is we are going to have is clock, a clock. And let's say this is our master. Okay, so the very first signal which we are going to have our clock signal, and it is a global clock signal, and all the signals are sampled on the rising edge of the clock. And this AXI protocol is also a synchronous protocol. And next signal we are going to have is a reset n, and it is a active low reset, a reset n, and it is a active low signal which we are going to have. And next is AW address signal. Now this AW address is nothing but my write address signal. So the write address bus gives the address of the first transfer in a write bus transaction. The associated control signal are used to determine the address of remaining transfers in a burst. Now, so this AW address belongs to a write address channel. I will write down here. So this AW address belongs to my write address channel. What do you mean by write address channel? We have discussed in our previous sessions only. So the write address, and this write address is basically used to give the address of the transfer, and the associated control signals are used to determine the address of remaining transfers in the burst. So in a burst transfer, the very first transaction address is given by this write address, and the remaining transactions or the remaining packets address are given by other control signals that we are going to learn later. Okay, and next we are going to have one more signal, that is nothing but AW length. So this also belongs to our write address. This AW length is basically used to tell you the burst length, like what is the length of your burst, whether it is a, so this AW length is going to tell you the burst length. So this AW length is going to tell you how many transactions or how many transfers are going to present in a particular burst, and this information is going to determine the number of data transfers associated with that particular address. Okay, that we are going to learn further what do you mean by burst, and how this AW length is helping, and how it is helping, and how we are going to calculate the number of transfers which are going to have in that particular burst, that we are going to learn later. Okay, next signal which we are going to have is AW size, and this is the signal which is associated in our write address channel only, AW size. And these two are our control signals, and this is our address signal. Now what is this AW size is basically describing us? This AW size is describing the burst size. This signal basically indicates the size of each transfer in the burst. Okay, so byte lane strobes indicate exactly which byte lane to be updated. That we are going to learn. Okay, that we are going to learn further. Let's say if we have a simple master and slave like this, and the master wants to send 4 transactions like this at a time, then this is nothing but a burst, and the size of burst is nothing but we are going to send 4 transactions, like so that's why the size of the burst is nothing but 4, and the size of the burst is determined by this AW length. Now what is the size of each packet? That is determined by AW size. Okay, so this is how, using this AW length and AW size, we are going to decide what is the length of the burst and what is the size of each data packet we are going to send it inside our burst. Now in our AHB protocol, we were having some signals like H burst and H size. So for determining the length of the burst, we were using our H burst there. Here we are using AW length, and for determining the size of the data, we were using H size there, and here we are using AW size. This is the difference between AHB and AXI. Next we have going to have something known as AW burst. it is going to tell you the burst type. So this is nothing but AW burst. Let me write down here. This is my AW. So this is going to tell you what type of burst we are going to have, whether it is an increment burst or wrapping burst or single incremental burst. In our AHB protocol also we were having this burst which is known as H burst. Okay. So this AW burst will also come into this category of write address channel. AW burst will come into write address channel. Okay. And we are going to have something known as next we are going to have something known as AW valid. Now this AW valid is going to tell you whether the address which was given by our master is a valid address and the control information which was given by our master is a valid control information. This signal indicates the valid write address and control information are valid or not. If this signal is equal to 1, then the address and control information which were given by the master is a valid information, or if it is equal to 0, then the address and the control information which was given by our master is not a valid and control information. So the address and control information remains stable until the address acknowledge signal, that is AW ready, goes to high. For example, let's say this is our master. Let's say our master is going to use a channel which is known as write address channel. Using this write address channel, the master is going to provide all the address and control informations like our AW address, AW length, AW size, AW burst, all these particular signals. It is going to provide all the address and the control signals the master has provided using our write address channel. Now and it is also going to provide one more signal which is known as AW valid signal. So using this signal, the master is going to tell the slave, the master is going to assert the slave that yes, the signals, the address and the control signals which I have sent are valid signals, you can sample them. So using this particular AW valid signal, the master is going to tell the slave that all the information, all the address and control information which was sent by the master are valid only. So if the slave sees this AW valid equal to 1, then the slave confidently, it can sample those signals, all the control and address information which was sent by the master, it is going to sample them. Okay, this is the significance of this AW valid signal. And we have something known as AW ready signal. Now this is an acknowledgement type of signal. Now this AW ready signal is like a type of acknowledgement signal which is going to given by our slave. Now after master providing the address and the control informations, the master is going to wait for the response from the slave. Like if the slave has if the slave has sampled all those particular address and control information or not. If the slave has successfully sampled those address and control information, then the slave is going to provide a response that is nothing but AW ready. Now if the AW ready signal is equal to 1, slave is ready and it has successfully sampled all those address and control information. If the AW ready signal is equal to 0, that means slave is not ready for the transfer and it is not yet sampled those address and control informations which were given by our master. Now let's say if our AW ready is equal to 1, then in the next cycle the master can deassert all the write address and control information, or it can change the write address and control information which was given. But if our AW ready is equal to 0, the master is not allowed to change the address and control information which was given. Okay, so using this AW ready signal, the master is going to wait for the change of this particular signals. So this AW ready signal is given by our slave to the master. So these are the signals which we are going to use in the case of our write address channel. So in the case of our write address channel, so using this write address channel, we are going to pass the write address and control informations, and we are going to get the response that is nothing but our ready signal from the slave. In AHP protocol also we have seen this ready signal, that is H ready signal. H ready is going to basically tell whether the slave is ready for the transaction or not. So until and unless your ready signal is equal to 0, you're not supposed to, the master is not supposed to change the address and control informations. Okay, anyways, we are going to learn the same thing in more detail in our AXI protocol also. If you haven't watched those sessions on HP protocol, don't worry. Okay, So these were the signals which were associated with write address channel. Next we are going to have some another set of signals for our write data channel. So this is the second channel which we are going to have. Previously we have seen the channel signals which are associated with our write address channel. Now we are going to see the next set of signals which are associated with our write data channel. Now in the case of our write data channel, again we will have a master. So the very first signal which we are going to have is W data. This is also input, sorry, this is the output of our master. W data is our output of a master. Now what is this W data? So this W data is the write data. After, let's say if our master wants to send some data to our slave, first it has sent all the write address and control information which are necessary for sending a data. After receiving the response from the slave, that is using the using the AW ready signal, that is it is successfully sampled all the address and control information and it is ready for the write data. Then the master is going to provide the data to the slave using this W data signal. Using this W data signal, it is of 32-bit width. Using this W data signal, it is going to send the data, actual data information to the slave using this W data. Okay. Now this particular data can be of 8-bit, 16-bit, 32-bit, 34 bits width and so on. Okay. And next we are going to have something known as write strobe. This signal is basically going to indicate which byte lane to update in the memory. That we are going to learn later. And next we are going to have something known, I will write down here, write strobe. And next we are going to have is W last. It is going to basically indicate the last transfer in a write burst. Let's say if we have a 4-bit burst, then while sending this particular data only, our master is going to tell that this is the last transaction. Okay, so using this W last, it is going to tell that this particular transfer is a last transfer in a burst. Let's say this is our master and this is our slave. So master is going to write the data using the W data bus, and also it is if it wants, it can use the W strobe also, and if it is a burst operation, then it is going to use W last. Now all these particular signals, the control and the data signals which the master has used, now the master is also going to use one more signal that is known as W valid signal, and it is going to tell the slave that all the signals which the master has sent during the write operation are valid. So if these signals are valid, then the W valid is going to be 1 and the slave will come to know that okay, the master has sent all the valid signals. But if the W valid is equal to 0, then the write data and all the control signals which the master has sent are invalid. Okay, so these are the signals which we are going to use for asserting them. And after receiving this particular information, the slave is going to acknowledge the master using, after receiving the signals by the master, the slave is going to acknowledge the master using another signal which is known as W ready. So using this W ready, the slave is going to tell the master it is ready for the transaction or it is not ready for the transaction. If W ready is equal to 1, then the slave is ready and it has successfully sampled the write data signals and all the signals which are associated with write operation. And if it is equal to 0, then the slave will acknowledge that it is not ready and it is not yet sample those particular signals. So using this particular signals, it is going to communicate with our slave. So these are the signals which are associated with our write data channel. These are the signals which are associated with our write data channel. Next we are going to have some more signals which are associated with our write response channel. So now we have seen our write data channel, write address channel, write data channel, and we have also, so we have seen about our write data channel and write address channel. Now we are going to see another type of signals which is known as our write response channel. If you can see here, all the signals, if you can see here, the channel, if you can see here, the signals which are associated with our write address channel are written with A. The signals which are associated with our write address channel are associated with AW. and the signals which are associated with our write data channel are associated with W, and the signals which are associated with our write response are used with the letter B. Okay, now let's say we have a master and a slave. Going to have in our write response channel is B response. Now this B response is nothing but it's a write response. This signal is going to indicate the status of write transaction. If it is okay, then our B response will be equal to 0 0, or if it is exclusively okay, it is going to 0 1, slave error 1 0, and decode error error. So these are the type of responses which we are going to have. For 0 0 we are going to give okay, and 0 1 we are going to have exclusive okay, and 1 0 we are going to have slave error, and 1 1 we are going to have decoder error. Okay, so these are the different responses which were given by the slave to the master. So the slave is going to use this B response signal in the write response channel for giving the responses to our master, and after slave giving those responses to our master, the slave is also going to use one more signal which is known as B valid to indicate the responses which were given by the slave are valid or not. If B valid is equal to 1, then the responses which were given by our slave are valid responses, or else if our B valid is equal to 0, then the responses which were given by our slave are not valid. Okay, so using this B valid signal, we are going to indicate the responses were valid or not. And next signal which we are going to have is B ready, and this B ready signal is given by our master. Now this B ready is basically response ready. So the signal indicates the master can accept the response information. And if it is equal to 1, the master is ready, and if it is equal to 0, the master is not ready. So using this B ready, the slave will come to know that the master is ready for accepting the responses, or else it is not ready for accepting the responses. If your B ready is equal to 1, the master is ready to accept the responses, or else if your B ready is equal to 0, then the master is not ready for accepting the responses. Using this B ready, the master is going to tell the slave. Next, we are going to have another set of signals which are associated with our read address channel. Those are nothing but AR address, AR length, AR size, and AR burst. Now, what do you mean by AR address? So, let's say if our master wants to perform a read operation, this is our master and this is our slave. Let's say if our master wants to perform a read operation. Previously, if the master wanted to perform a write operation, it was sending the address information and the control information which was associated with that particular write data operation using AW address bus. But here, if the master wants to perform a read operation, then the address and the control information which are associated with this read operation are going to send using the another channel which is known as read address channel. Specifically, if the master wants to send the read address, it is going to use the address signal which is known as AR address. It is going to use a signal which is known as AR address. So if you can see, the letters associated with this address channel are AR. Okay, now this is read address, and the read address bus gives the initial address of the read burst transaction. Only the start address of the burst is provided, and the control signals are issued alongside the address detail, how the address is calculated for the remaining transfers in the burst. That we are going to learn later, how the address and how the address is given in the burst and what are we doing, that and all things we will learn later, but understand the significance of this particular signal. Next, if we are performing a burst operation, then especially if we are going to perform a read burst operation, then the information for the length of the burst is given by our AR length. AR length. So this signal is going to indicate what is the length of the burst and what should be the size of each packet or each transfer in the burst, that is given by our AR size. Same as your AW size, AR size information, AR size is going to perform. And next is AR burst. It is also same as your AW burst. So these are the signals which are associated in our read address channel. Next set of signals which we are going to have is read response channel. Now, In this read response channel, we will have two type of signals, which is nothing but AR valid and AR ready. The this particular signal functionalities are same as your write response channel. Those we have discussed in the write response channel, the functionalities of those which we have discussed in the write response channel, though same like that, this AR valid and AR ready are going to work. That's it. Okay, there is no difference. The major difference is these signals are present in read response channel and those signals are present in write response channel. And next we are going to have read data channels. Again same, in the write data channel, whatever the signals we were having in the read data channel, we are going to have this type of signals. And after master sending all the data and address control informations for reading the data from the slave, it is not going to use another channels like write data or something. It is going to use this read data channel. Especially it is going to use this R data signal for reading the data from the slave, and for giving the response, and for getting the response, read response from the slave, it is going to use R response. And for indicating it is a last transfer in a transaction, it is going to use R last. And for saying for the slave, and the slave also uses this R valid signal to indicate whatever the information it has given is a valid information using this R valid signal. And the master is going to provide a R ready signal indicating that it is ready for the transaction to be taken or ready for a read transaction. Now let us try to understand the difference between your AHB and APB, how they look. So these are the signals which are associated in our AHB protocol, where we are going to have H clock, H reset in, and the master is going to provide the H address information, H burst information, H trans information, HW data, H write, and it is going to receive HR data and H response. So these are the signals which are associated. Let's say if I want to perform a write operation, that is the master is going to send the data to the slave. I want to perform a write operation. Then how I am doing this in AHB protocol? First of all, I am going to provide the address signal which is associated with that particular transaction. And next, if it is a burst transfer, then I'm going to provide the burst information using H burst. And if it is a idle transfer, okay, first of all, I will write down. I'm going to provide H address information, and I'm also going to provide the burst information, what type of burst I'm going to perform. And I'm also going to perform the transfer information, like what type of transfer I'm going to perform, whether it is in non-sequential, sequential, or a busy transfer. Okay. And after that, I'm also going to give the write control information. If it is a write transfer, I'm going to perform H write is equal to 1. And next, I'm going to provide the data using HW data, and I'm going to check the readiness of our slave using H ready signal. These are the signals which I'm getting from the slave. So using this H ready, I'm going to check for the readiness of our slave, whether my slave is ready for the transaction or not. And I'm going to provide the data using my HW data bus. This is in the case of my write transfer. Now, if I want to perform a read transfer, then what I was doing, I was providing the address signal, and I'm also providing the write signal and the transfer type, and also I'm going to check for the burst signal, and I'm also checking for the H ready signal. And after that, I'm receiving the data using HR data bus. This I was doing in my AHB protocol. Now in AXI protocol, this is my master and slave interface. Now, if I want to perform a write operation, then the master is going to use write channels like write address channel. This is my write address channel, and it is going to use a signal which is known as AW address. AW address, and it is also going to use AW data, and it is also going to use AW valid signal for indicating all the address signals which it has given is or valid signals, and AW burst and AW length for indicating the length of the transfer, and it is also going to get the response, that is AW ready. So these are the signals which are associated in the write address channel. Okay. Next, it is going to use another channel which is known as write data channel. So using this channel, this is our write data channel. Using this channel, our master is going to send the actual data which is associated with the address, write address. That is nothing but my W data, W stroke, and W valid, and our W ready. Like this, we have dedicated channels for each and everything. Okay. Next, what we in HB protocol, we were having only one ready signal for getting the readiness of our slave. But here, for getting the readiness of our slave, for address we were having one signal, and for data we are having one signal. Okay. Next, for in the case of read operation, we have different channels: read address channel, read data channel, and read response channel, and write response channel. For getting the response for the write operation, we have dedicated channel, and for getting the read response, we have another dedicated channel. So we have different dedicated channels for different things. We have different channels dedicated for different operations. So this is about our channel descriptions and different signals which are present in our different channels. Yes, so that's all about this particular video. If you like this video, please like, share, and subscribe to my YouTube channel all about VLSI, and please provide your valuable feedback so that we can improve ourselves and we can provide more quality content. Thank you for watching this video.